students, welcome to TechGKCM, the official YouTube channel of our college. Today I will discuss about Euler's theorem for simple connected planar graph. So, the Euler's theorem, statement of Euler's theorem for simple connected planar graph is if G is a simple connected planar graph with n vertices, e edges and f faces, then n minus e plus f equal to 2. We will prove this theorem by applying method of induction on the number of edges of the graph. So we are taking a graph, let G be a simple connected planar graph with n vertices, e edges and f faces. So we will use mathematical induction on the number of edges, that is E. Now, the minimum number of edge in a simple connected planar may be 0. Now, if E equal to 0, the graph will be like this. There will be only one vertex because the graph is connected graph, otherwise it will be disconnected if number of vertex more than 1. So this is the graph for E equal to 0, where n equal to 1 and f number of face is 1, that is infinite face. So n minus e plus f will be 1 minus 0 plus 1 equal to 2. So for e equal to 0, our theorem is satisfied. Now we take e equal to 1. If e equal to 1, that is number of edge is 1. The graph will be like this. There will be two vertices, that is n equal to 2 and f equal to 1. That is the infinite face. Now we will check the equality. N minus e plus f is equal to 2 minus 1 plus 1, that is equal to 2. So for e equal to 1, the equality holds, n minus e plus f equal to 2. Now we can check more. If e equal to 2, then the graph will be like this. Okay, that is n equal to 3. There are 3 vertices and f equal to 1. So n minus e plus f equal to 3 minus 2 plus 1, that is 2. So for e equal to 2, Euler's theorem is also satisfied. Now we are assuming that the theorem is true for fewer than e edges, and we will prove this theorem for the graph containing e edges. We will prove this theorem for the graph with e edges. I am not mentioning the number of vertices and faces separately because they are always same, that is mentioned in the statement. Number of vertices is n and number of faces is f. So I only wrote that the graph has e edges. So our assumption is, the assumption is very important. Our assumption is that the theorem is true for the graphs with fewer than e edges, that is less than e edges. We will prove this theorem for the graph with e edges. Okay. Now, a simple connected planar graph may be of two types. Either it will be a tree or it will not be a tree. If it is a tree, case 1, if G is a tree, tree means there will be no cycle, and we know that in a tree with n vertices there are n minus 1 edges. So if G is a tree, tree is like this, there will be no cycle. A connected acyclic graph is called tree. This type of graphs are called tree. I am just giving an example. And we are proving in generalized way for all graphs, for all trees. If G is a tree, that is number of vertices is n and number of edges is e, that is n minus 1 here. In a tree, if the number of vertices is n and then number of edges is n minus 1, and f will be 1, because since there is no cycle in a tree, so the face is infinite face, only 1. Okay, so n minus e plus f equal to, n is n, the number of vertices is n, minus e equal to n minus 1 and f equal to 1. So n minus n plus 1 plus 1, n is cancelled out, that is equal to 2. So if G is a tree, then Euler's theorem is satisfied. We have proved this. Now we will consider the second case, if G is not a tree. Case 2, if G is not a tree, that is there will be at least one cycle. I am giving an example for simplifying the proof. We will prove this in generalized way, that is for all graphs which are not tree. This is a tree, and if this is not a tree, then there will be at least one cycle. So I am making cycles, maybe more than one cycle. Okay, this is not a tree because there are two cycles. Now, and this graph has n vertices, e edges and f faces. Now we are taking an edge from a cycle. Suppose we are taking this edge and naming this edge as E1. Okay, this graph is, remind that this graph has n vertices, e edges and f faces, and the name of this graph is G. We have selected an edge E1 whose name is E1, and we are deleting this edge from this graph, that is G minus E1. So these were the number of vertices, edges and faces in the graph G, and in G minus E1 what will be the changes after deletion of the edge? The number of vertices will be same, n. The number of edges will be reduced by 1, since we have deleted only one edge, that will be e minus 1, and number of face will also be reduced by 1, because after deleting an edge from a cycle, the cycle remains not a cycle, so this will be f minus 1. Now since G minus E1 has less than e edges, then we can apply our assumption, which was that Euler's theorem was true for all the graphs with fewer than e edges. So G minus E1 is a graph, is a simple connected planar graph with n vertices, f faces, and the number of vertices, number of faces is not important. Our assumption was Euler's theorem is true for all the graphs with fewer than e edges. So G minus E1 has less than e edges, e minus 1 edges. Okay, so we can apply Euler's theorem in this graph. So n minus e, here e is e minus 1, plus f, here f is f minus 1, equal to 2. We can write this by our assumption. By our assumption after applying the mathematical induction. Now if we simplify this, 1 is cancelled out, so n minus e plus f equal to 2. Hence the theorem is proved for the graph, simple connected planar graph, if it is not a tree. So Euler's theorem is true and proved for all the graphs which are tree and not a tree. Thank you.